This is a video on isotopes, which is what you did last lesson. Just wanted to give you a sort of overview of it. So on the periodic table, if you had carbon, it has 6 as an atomic number, 12 as atomic mass. So that means that it has 6 protons, because this atomic number tells you how many protons it has. And this number tells you how many protons and neutrons it has, which is its atomic mass. The reason that is the atomic mass, protons and neutrons, is because electrons are so small that they effectively don't have a mass. So protons and neutrons, when you add them together, that's the mass of it. Now, what an isotope is it can have a different number of neutrons. So if it had 14 as this number, but 6, still got 6 protons. Don't worry about the electrons for a minute. But it's got 6 protons and 8 neutrons. Just quickly going over why there's 6 electrons. This doesn't have a charge, so if it had a plus or a minus, it would have more protons than electrons, or vice versa. So the reason it's 6 protons and 6 electrons is because there's no charge there. These are positive and these are negative, and these don't have a charge. Don't worry about that too much in a minute. All we're worried about at the moment is that there's 6 protons and there are 6 neutrons, whereas in what we call carbon 14, which is an isotope of carbon, most of them are carbon 12. So that's why on the periodic table it's technically 12.01, because there's some of them are carbon 14. So this one has 6 protons and 8 neutrons, which makes 14. So our definition of an isotope is that it's a different number of neutrons but the same number of protons. The number of protons defines an element. So if it was 7 protons, it'd be nitrogen, it wouldn't be carbon. Whereas it can have 8 neutrons, or it could have 6 neutrons, it's still carbon. So then working out overall the relative atomic mass, people always ask me when I say, can you write down how many neutrons there are in chlorine, sorry. Well, it's got a 0.5. So I'll show you why it's got that 0.5 now. So 75% of the world's chlorine is 35. It's got a mass of 35. But then 25% is 37. Now, if you did 35 just plus 37, then you divided it by 2, you'd get 36. But that's not relative. There's a lot more of this one than there is this one. So you can't say that. Okay. So the way of doing that is you times the mass. So we had 35 by the percent. So 35 times 75, that's 2625. And you do 37 times 25. Add that all together, so that'd be 2625 plus 925, then divide it by 100, and that would give you this 35.5, and that is why you see that on the periodic table, is that. Okay, thank you.